Alright, so today we're going to talk about the first part of chapter 4, designing a database. So chapter 4 is pretty long chapters. So the first part is going to be designing a database, and then we're going to implementing the database and how we set it up, and then the final one would be doing the querying language, like how we retrieve data from the database. So first off, database system. What is really a database system? It is a collection of related data for various users. So let's just think of the related data would be like a table. So you have one table for customers, so that would be like all of the customers' information, and you have one table for all the sales information, and then you have informations about the accounts receivables and so on. So all of those are like a little bit of data, and then the database would be the system that hold all of those data together. Well, we have to think about data and the use of data as separate considerations. Well, why is that? Because we don't always know how data might be used when we are setting up a system. It's like there's some information that you might need in the futures, but not really relevant for now. You want to keep it, but you don't really know that how we're going to use it now. So we still want to have that in the database system without knowing how to use it. I mean, how it might be used in the future. Why use a database system? Oh, you have to ask yourself, what is the alternative approach? That is called the flat file approach. So what is a flat file approach? Remember, database is collections of data. Flat file approach means that you store data in one place. Essentially, every single data point, you're going to have it in one table. So what's wrong with this? Well, you can still store data in that way, but it's not really efficient because it's created a lot of data redundancy. It takes up a lot of storage. Because of that data redundancy, it has a problem with data updating in currency. So let me talk about that. So let's say if the marketing department needs to store data about customer information, right? Because they're gonna send out some flyers and advertisement to those potential customers and current customers. Now, accounting department also need to have that storage of customer information. So essentially, if there's no database, each department is gonna have their separate customer information data in the different places. So that's create data redundancy. Now it takes up storage because instead we have memory, now you have, it's twice. It's double the speed of memory. It also the problem with data updating. Let's say the customers come in and say, oh, I changed my phone number. And if the person they meet is from marketing department, so the marketing department is going to update that information, but that not be able to transfer that information to other department, for example, accounting department and finance department instantly. So there's a problem with data updating. So that also brings the currency. The currency here is not the dollar side value. Currency here is like how the data is up to date. It's most likely who is going to have the most up-to-date data. And that also created the problem with full centralized database to integrate and combine the data. Now, thinking about the customer information table again, if we store everything in one place, let's say accounting department, we're going to have all the journal entries, we're going to have customer information, sales information, every single thing in one place. Well, let's say if we want to check for account receivable, then that person, account receivable person, have to go to the same main tables to pull data from. Now, at the same time, if other people want to use that same tables, that can create various like errors because if one person make mistakes, so everyone else we're gonna get the same errors data. Also, it has to go like sequential because it's like you open a file and you cannot access the file all instantly at the same time. So it's very text data dependency also. Now, if you look at this flat file environment, so this diagram will kind of illustrate how it works. So let's say we have user one in transactions, go to program one, so we don't know which program it is, and then we have table ABC. Now user two transactions go through program two. It can be a different software program. Let's say the first one use enterprise system like SAP, and the second one use Oracles, and we create tables like XBY. And user three transactions use Microsoft Access as the database management system, and then they have the tables LBM. Now, obviously, you can see the data redundancy because essentially three users have created the same table B. So we have three places to keep table B. Now, instead, if we have database approach, then all of the users are going to go through either program 1, 2, and 3, but then they're going to go through that database management system, which combined everything. And so essentially, we have the whole database contains A, B, C, X, Y, Z, L, M. So all of the data that's needed by user 1, 2, 3, without redundancies, like we create, triples, like 3 tables B at the same time. Okay, what's the nuts and bolts? All right, database management system is a software that lies between data and user. So it just kind of translate all of the pool data. It's called querying it. So it can create a tables based on. So basically, it can customize table based on its needs. It control access, storage, and retrieval. So we don't want to have every single one to have the same access to different table. So what if table A is going to be like a top secret tables that we only want to have a certain people in charge to access to those tables. So the database management system also can control the access, like if you have the authority to access to those tables or not. It also provides usage reporting, so it's just going to give you standard customer reporting. Now, database system is going to have data dictionary. So data dictionaries means that things that defines data fields. Basically, you're going to have in each tables. Right, so this is examples of a table, right? So we have reservation IDs, customer IDs, and customer name, and so on. So those things attributes, right? That's what's only we know. But think about the database. Database have thousands of attributes and thousands of classes. Like we have different classes. So for somebody to know, like, well, what is reservation ID? We need to have data dictionary to have to explain those things, to describe those things. So reservation ID is what, customer ID is what, customer name, and then how we format them. Reservation IDs should be sequential number, for instance. Customer ID should be like 3-digit numbers and so on. So database administrators is the one who manage database resources. It's involved, and he or she involved in planning, design, implementations, operations, maintenance, security, growth, and change of a database. The database change and grow as the company grow, right? So new informations come in constantly every day. Like we have new customers, or some old customers need to go out, and then we have sales every day. So we just have to kind of planning, designing the database so that we can manage all of that efficiently. Again, you can read up more of these definitions in the text. Now, this is pictures from IT, but essentially, I just wanted you to understand user is usually the one who want to get the data from the database system, right? Users use some programs. Sometimes they insert data into the database system through different programs. Let's say if the cashiers want to enter sales, they have a different program. If the marketing person want to enter customer information, they have different programs. So we can have different applications, and then it's all go through the database management system, which give us some kind of standardized data to everything. And so then we have a storage, is the physical database. So database administrator is the one who kind of controls and manage all the things happening in database management system. The question is it only one type of database? No, it is not. There's many type of data. We have hierarchical data, so it's like a tree-like structures using mainframe system. So company, if they have like project one, if we can divide it a project 1, 2, so it's just more like parent-child relationship. And then, from projects 1, we have team A, B, and so on. And projects 2, we have team B and C. So the problem with the hierarchical database is that it's not very flexible because, let's say, if projects 2 want to access certain information from team A, then it's very difficult to do so. It's not very flexible. So network database another type, so it just give us more of the flexible, but again, it's still like lattice structure. So even though it's provide more flexibility, but it doesn't really connect everything together. Essentially, that's what it means. So that's why in our course we're gonna focus on relational database, because if we separate that into like different tables and everything can be connect or linked, those provide greatest flexibility. Yes, so like I said, relational database is very flexible. It's scalable. Scalable means like if the data grow, let's say we have additional one more records of customer information. What if we have um, a million more customer information? Um, it can accommodate for those change. It's very simple. It's also tackle the problem we have with flat file system. It's always make sure that the data is updated and there's less redundancy. Now you can see that we should not have any redundant tables. So if we have one customer table, it should be in one place. And then if somebody history data and entering data, it can go to a different application and just go to the database system. So different users can access to their certain piece of data at the same time. Well, what is the drawbacks? It can be costly to implement, right? So instead of one tables, everything, maybe you can just use the Word or Excel to manage the table. Now, if you have database system, obviously you cannot use some simple software like that. Probably you need to have more advanced software. So it can be costly to implement. Also, you have to update all the computer system, like additional hardware, software, storage, and network resources are required. It can only run in certain operating environment, so it may make it unsuitable for some system configuration. So it's not really compatible. Like you have to, if you use one database system, it just have to go in its certain way and format. Because it is so different from file-oriented approach, the database system requires training users. So usually if you introduce internet new technologies, it can be, people can be resistant to new changes. It takes a while for people to get used to the new technology and adopt. So that is one of the problem as well. And when we do deal with database system, management system, if company want to upgrade to database management system. And then the also problem is that all information in one place. Now, I said before, the benefit also isn't that all information in one place, so we can reduce data redundancy, but at the same time, it's more prone to cybersecurity. So what if there's some disaster or cybersecurity attack? That means that we are vulnerable to lose all data at once. So there's a risk there. So whenever you use database system, be aware you need to have a backup data file in place. Now, so focus on relational database. So let's talk about step in relational data modeling and designing. First off, you need to identify classes and create tables. It's just like when we do UML class diagram. So that is actually the blueprint of relational database. So you actually kind of, designed it in using the diagram, and now you're going to have the same thing. basically, if you identify class, that means that one class is one table, so you can create tables based on a class diagram. Now, then we need to identify attributes for each table and the primary key. Remember, the primary key is the unique instance of that table. Now, if I show you this table, this looks like a reservation table. So this is one table, and then we have the reservation tables have different attributes. So reservation ID is one attribute, customer ID. So essentially that is the headings or column headings or view titles. That is called the data field, right? Customer name, ISBN, book titles, reserved dates and status, and so on. Now, every single table we need to have primary key, because that is the uniquely ID to uniquely identify each instance in the tables. So you can think of each instance or record each as one row. So each row is uniquely identified. So what can be uniquely identified in reservation table? It should be reservation ID. So these cannot be duplicated, essentially what it means. So if we don't have that in one table, then we can create that. Usually we can create that in a database management system, say that, create a sequential number. Actually, that remembers in UML class diagram, we talk about identify multiplicity to determine keys, because this is where we want to see that whether we're going to need to have foreign keys or we need to have a linking table, right? So if we have the many-to-many relationship, that means that we need to have a new table, linking table, and then the primary key would be the composite primary key. So that means that the primary key of that new linking table is the combinations of the two tables primary. So let's say if I have a customer tables, would be customer ID is the primary key, and then I want to link that with, let's say, sales, and sales ID would be the primary key sales ID. So if that is the many-to-many relationship, then the composite primary key would be customer ID number plus that sales ID number. So let's say we have the customer ID would be C1 and then sales would be S1. Then we can have the composite primary key is the combination of C1 and S1. That's essentially what it means. Alright, so finally, if we determine that whether it is many-to-many relationship or just like a one-to-many. Now, if it's one-to-many, then you will need to have your foreign keys, right? So you're going to post the foreign key to what the many side. After that, we're going to link each table with foreign keys or using a linking tables with composite primary key. So basically, this is the final step when we're setting up the database. Now, let's recap what would be the relational database golden rule. Remember, data is stored in one place and one place only. We don't have duplicates. So let's say we have customer information, customer table, sorry. So if we have one customer table, it should be just in one place. Every single customer information should be stored in one place. We should not have another, let's say, a customer table, not even the same name or same content, right? Yes. So talk about data redundancy. We're talking about like how we update the data, because why do we want it to be in one place? Because we want our system to update all users when change have been made to a customer table. If sales department update the customer account, then every single other department should have the same update. If the customer changed phone numbers, the sales department update the account, then the accounting, marketing, finance, operations department, and so on should have the update information about the phone number. Right, so we want all users to be updated when new customer and insert. We want all users to be updated when all customers are deleted. All right, let's recap some basic requirements. We have entity integrity. Means that every single tables. So one class is one table. So customers, book, and employee. Each of them should have primary key. So that is entity integrity. Each of the tables must have unique primary key and is not null. So the primary key field cannot be empty. So here, if you remember from our previous lectures about primary key, for example, this table, we have book ID as primary key. Employees ID can be a primary key, but seems like a customer table, we don't have primary key yet. So we should have the primary key for customer table. Remember, primary key should not be something that can be like the same name, right? So customer can have the same name. So we don't want to have that because primary key should be unique. We don't want to have a phone number because it can change over time, and same as email address. Right. Referential integrity only allows change in the original tables. Now once I have the table set up, I may have the customer's ID in one of the tables in order to link those tables together. So let's say if I have customer ID in the book ID so that I can link what customer purchased which book. Now, even though that would be the case, if you want to change the customer ID, it should happen in the customer table. It should not happen in the book table, even though you may have one attribute about customers in book tables. So that is referential integrity. Each attribute must have a unique name. All values of each attribute must be the same type. So Excel should have single value cells, mean each cell should have just one single value. It should not have multiple values for each cell. And it's very important in terms of how we link the tables. So let me show. Let's say here we have reservation 1 and we have customer ID. So each cell here, this is one cell and should just have one value. Even though it's not the primary key, but we should not have, like, let's say if one reservation and customer John Doe, and then I want to reserve several books, then we want to create another reservation ID for that, right? 101, and then we have John Doe, and I'm just doing ISBN 124 and save Animal Farm. So again, except for the primary key, we can have duplicate in others, but we should not have something like this. Now, customer John Doe, and then we get if he reserved 2 books, and then we put those in the same field. So this violates what is called the single value field requirement. Finally, all non-key attributes must describe the object identified by the primary key. Right. So if we have the customer table, then we should not have what describe sales in there. We may have sales ID as a primary key so that we can link with sales table, but we should not have any additional information other than that for us to sales. We should not have like the sales date and then so on, because those things should belong to the sales table. So every single other's attributes in the customer table should describe the customers. Let's say customer name, his phone address, or its physical address, his email address, and so on. Now we have a lot of data. So the question is how many tables? The rule of thumb is that we want to divide data into nut tables until your database is functional. There's a formal process for doing this. It's called normalizations. But let's make it easy and just split up the big and common sum tables into some smaller and more useful one. Now, I just want to use this to kind of illustrate how we set it up the database. But it's not really something you have to do in any of this exercise or test. So think of a data table as an Excel spreadsheet with rows of data. So each row would be a record. Okay. Consider tables for UNO. So we have a table for UNO that has student information including ID, name, major, course enrolled. We want to ask the questions before we kind of split the tables. Something you want to think about: can a student take more than one course? Well, likely yes, right? So if you're full time, then you probably want to take at least like 4 to 5 courses. If you are part time, then you sometimes you take like 1 to 3 courses. So it depends. But the answer is yes, it's possible for a student to take more than one course per semester. Can students be admitted to UNO before taking any class? Well, the answer is yes. So there is a conditional admissions, like so sometimes you cannot have to fulfill certain requirement before you can fully admit it, but a student can still be admitted, still taking a class. What if you take class for an additional certificate, or you just want to take one class for fun? So it's possible to have that as well. Can a student drop a class at UNO? Yes. Um, if a student can drop an English class, but then they still taking another class and they still be enrolled and they can take that English class later on. So it's possible for a student to drop a class and still be enrolled at UNO, right? So this is examples of the tables. So let's say we just have every single information in one. Now think, it is totally useless table. It's definitely not usable. Why is that? Think about that. First of all, uh, we do we have several course ID and several course names, one cell. So it's not really a single cell value. Now, what if the marketing department want to change the name marketing to MKT 208 to stop promotions? If you do that, then you have to think about go to all of the records in that tables and change that name to stop promotions. It doesn't change automatically. So if we only have 5 records here, but what if we have million records, which is something very normal for a database? Then it's very difficult to change. You have to go to every single record to change that name. What if the College of Football decided to add a new course, ring selections for fall 2018, but no one enrolled yet? So because no one is enrolled yet, and here's the tables, we have just the student measures and course ID. So we don't have any information. We cannot create information that if there's a new course and then with no students. Now, what if Kim Kardashian change her mind about school and decide to drop out, becomes a professional motorcycle rider? It's possible, but then what are we gonna do with your record? If we let's say if promotion she's the only one who takes branding, then if we drop her record, so do we just also accidentally delete also the course and course ID about branding? So those are the things you want to think about when you do the database. And again, we don't really have unique identifier in table. So what if instead of that table, then we split into 2 tables? So now we have a name, student ID, and we have a first measure. So we still have one table based on student ID, right? And then we split the single value the double value cell into like a single value cell. So we have one column for first measures and the second column for second measures, and we have a course ID. So we have course name and course ID. The problem here is one person can have double measures. So one measure can have certain course requirements they need to take, and then certain course belong to other measures. So what if the overlapping course for different measures? Then if we do that, it's going to mix up with the second measure, like which course belong to the second measure, which course belong to the first measure. It's not really clear if we just split into two tables in this way. Now, this one looks much better, and so now we have measure ID. So measure ID is going to be primary key for that measures table. So and then we have student names, and then we have course ID. And so we also think about, remember, the attribute should only describe what is the table is about, right? So measure ID and measure name only describe a measure. Same thing with student ID and name, and same thing with like course ID and course name. Now, you might have questions like, how do I create a report that lists student by measures and row by course? Does it mean that I have to access in three tables? That sounds so inefficient. Well, yes, you do have to access three tables. But with the data management system, it's just much faster using querying language that you only need can pull like information that you need. So you don't have to pull every single information in each table, but essentially you can kind of create the student name. So you can pull name from one tables, and you can pull measures from one table in the course name. So how do the tables communicate? Through primary keys and foreign keys and linking table, like we said. I'm going to talk about that in details in the next lecture.